welcome to the explainer. You know, you're going to do it about 22,000 times today, and you probably won't give a single conscious thought to any of them. Today, we're exploring the absolutely incredible journey of a single breath. It feels so simple, right? Just in and out. But behind that unconscious rhythm is a story that spans 400 million years. It's a high-stakes chemical ballet and a neurological marvel that keeps you alive, second by second. So in this explainer, we're going to follow the journey of one single breath. We'll start with its ancient origins, way back when the first creatures crawled onto land, all the way to the microscopic command center that keeps it all going. So let's dive in where it all began. Our journey kicks off about 400 million years ago, deep in the Devonian period. As the very first vertebrates started to venture out of the water and onto land, they faced this massive physiological challenge. How do you get oxygen directly from the air? Well, to survive on land, these pioneers needed a revolutionary piece of equipment, the lung. But, the first lungs looked absolutely nothing like ours. Evidence from living species actually shows they started out as just a single, unpaired sac in early bony fish. And you can see the difference so clearly right here. On the left, that's the lung of an embryonic fish, a Senegalbish to be exact. See how it develops as just one simple pouch budding right off its gut?
In these early fish, the left lung wasn't its own thing. It was basically just an offshoot of the right one. The true symmetrical pair of lungs that you and I have today, that didn't evolve until the ancestors of tetrapods, four-limbed animals like the salamander you see right here.
This evolutionary path really shows us how critical that move to paired lungs was. This one modification dramatically increased the surface area for absorbing oxygen, which gave those early land animals a huge advantage. And think about it, it also offered redundancy, a backup system in case one lung got injured. That's a key feature for survival. So it turns out they're not just simple bellows for moving air in and out. Nope, they are master chemists performing this delicate, high-speed balancing act that's happening inside you right now. Let's zoom way in, down to the microscopic chemical factory inside your lungs. This is where they perform one of their most critical jobs, maintaining your body's internal balance, something we call homeostasis. You see, every single cell in your body depends on maintaining this perfect chemical equilibrium known as acid-base balance. Your blood pH has to stay in this incredibly narrow, slightly alkaline range. If it veers too far in either direction, well, crucial cellular functions just start to fail. And to keep this balance, your body uses two key organs, your lungs and your kidneys. But here's the thing, they work on completely different timelines to keep your body's chemistry perfectly in check. Your lungs are the rapid response team. They control the level of carbon dioxide in your blood, which acts as an acid. So if your blood becomes too acidic, your lungs react, and I mean within minutes, by increasing your breathing rate to blow off more of that CO2. Now, the kidneys, on the other hand, they're the long-term strategists. They adjust the levels of bicarbonate, which is a base. But this process can take several days. So it's really the lungs that provide that immediate, life-saving adjustment, fine-tuning your body's pH with every single breath you take. So we've got these incredible chemical factories in our chest, right? But how does our body know exactly how fast they need to work? I mean, you can't leave a delicate system like this to conscious thought. And that's where the brain comes in. The answer is hidden deep in the most primitive part of our brain, the brainstem. It's an autopilot that has been running nonstop since the moment you were born. It's located in the medulla oblongata and pons, and this collection of neuron groups is known as the respiratory center. This thing works 24/7, generating and maintaining the rhythm of your breath without you ever having to think about it. This center is made up of 3 core groups, and each one has a very specific job. You've got the dorsal group, which sets the basic, quiet rhythm of just breathing in. Then the ventral group kicks in when you need more forceful breathing, like when you're exercising. And finally, the pontine group acts as the fine-tuner. And a really key part of this whole system inside the pons is something that acts as an inspiratory off switch. It's the signal that tells your body with perfect precision when to stop inhaling and start exhaling. This is what ultimately defines the rate and depth of your entire breathing pattern. So think about that. From a 400 million-year-old adaptation for life on land to a precise neural command center balancing your blood chemistry second by second, The simple act of breathing is one of your body's most incredible and most invisible masterpieces. It kind of makes you wonder, doesn't it? What other amazing things are happening inside you right at this very moment?